So we're going to start Chapter 2 now. And actually, you've already started Chapter 2. The first part, or the first objective in Chapter 2 is to learn the elements and symbols for the flashcard sheets that I gave you. So the pink and yellow flashcard sheets. So hopefully you guys have those mastered by now. As you probably noticed when you were learning those cards, it's very important to pay attention to capitalization when you're talking about elements. So capital C and capital O is something different than capital C lowercase o. So this is carbon monoxide. We'll learn how to name these coming up in Unit 2. Whereas this is an element, cobalt. And we're going to learn the difference between elements and compounds. But it's very important that when you're writing chemical symbols that you pay attention to capitalization, because there is a big difference between carbon monoxide and cobalt. So I've also put common confusions that occur between element symbols. For instance, K is the symbol for potassium, and P is the symbol for phosphorus. A lot of times, students will think that potassium is denoted by the symbol P, which it's not. That's for phosphorus. Same thing occurs with sodium, which is Na, and sulfur, which is S. Be careful with the G's. So Mg is magnesium, Hg is mercury, Ag is silver. Be careful with Mg and Mn. Mg is magnesium, and Mn is manganese. Ba is barium, B is boron, Br is bromine. Fe and F. Fe is iron, F is fluorine. Be careful with K, which is potassium again, and Pt, which is platinum. And then lastly, Fe and I. Fe is iron, and I is iodine. So I want you to write the symbols for fluorine, chlorine, and bromine. So fluorine is just F. Chlorine is Cl. Bromine is Br. What happens a lot of times when I ask this question, students will often put that fluorine is Fl. So be careful with that. Now, the periodic table that I gave you the first week of classes is going to be very handy to have around for this section of Unit 1. So I'm going to refer to it. I have it right here. The nice thing about this periodic table is it does have the element symbols and their names. So, if I'm just going to zoom in on lithium. It has Li and then the name of the element. So if you forget what the symbol is for a particular element, you can always look on your periodic table. It just happens a lot of times, these mistakes and errors that I've gone over, despite having the periodic table, students will make those mistakes. And so now that you know the element name and the element symbol is on the periodic table, if you're prone to make mistakes, say on, you always get these two confused, you can always double check yourself. So just know that it's there. Okay, so moving on in Chapter 2, we are going to learn about the periodic table. and how it's organized. So this periodic table that I've given you here contains a ton of information. There's a lot of information on here that we won't even get to, but don't let that intimidate you. It's a very useful tool, and the good thing is you will always be given the periodic table with the exception of the first quiz, which you've already taken by now if you're listening to this. So, the nice thing about the periodic table is it gives chemists the ability to explain chemical behavior. So the way they're arranged, there's a reason that the elements are arranged this way. So if you look on this periodic table that I have here, mine's in color, I don't believe that yours is, there are 3 categories of elements. They either fit into metals, nonmetals, or metalloids. And so the metals are on the left, and you notice that there are 2 types of metals. There are the main group metals and then the transition metals. So these are the transition metals, while these are the main group metals, and more main group metals over here. So metals, this category, they're on the left, predominantly left side of the periodic table. So you think of this as the left side. They are solid at room temperature, with the exception of mercury. Now, if you look on your periodic table, the states of these elements are indicated by the colors, and the key is, let me zoom in on this key. Right here. So I knew that mercury was not a solid because blue, the color blue, indicates that it's a liquid. So that's a handy thing about this periodic table. So the majority of metals are solid at room temperature. There's one exception, and that is mercury. These are good conductors. They're malleable, and then they're lustrous after cutting. Now, the nonmetals are on the right of the periodic table. You notice that this guy over here is really grouped with the nonmetals. And this element here is hydrogen. So hydrogen is not a metal, it is actually a nonmetal. So nonmetals are on the right. These are poor conductors, and you can find them in all different states. If you look at the colors on your periodic table on the right, you have red, black, and blue. So there are solids, liquids, and gases. Now the metalloids, these are also called semi-metals. And these have properties between, B/T is my abbreviation for between, metals and nonmetals. So the metalloids are this stair-step area, so it's kind of, I'm going to fill these in for you. If you look at your periodic table, you have boron, silicon, germanium, arsenic, and tellurium, antimony, and tellurium. So these are your metalloids. So they're kind of in between, not quite a metal, not quite a non-metal. Now I want to point out one other thing. Main group metals. Main group refers to, let me use my highlighter, anything that I highlight here. So this is the main group. So this area here, the transition metals are not a part of the main group. So the main group, we'll learn the group numbers, just the highlighted areas. Now this example periodic table I have here doesn't have this kind of island off to the lower right. We'll talk about that in a second. That's also transition metal, so that's non-main group area. Okay, so moving on to the next page. So I have two pictures here. Groups or families are vertical, while periods are horizontal. So, I'm going to number these groups, and you can do so on your periodic table as well. So this is group 1, this is group 2, this is group 3, this is group 4, 5, 6, 7, 8. Now the groups or families are vertical. So 1 through 8. And I'm going to put these letters here. You can add or omit these to your periodic table. I know it's different than your periodic table that you have. But this is the way it is in your book as well, the way I'm going to label it here. So 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. Now, these groups are also called families, so you'll have different names for a group. So it could be group 1A is also the alkali metals. So I'm going to go through these family names and then label them on this chart here. So the alkaline earth metals are in group 2A. So I'll write this here, alkaline earth metals. The halogens are group 7A. So the halogens, and they're given these names because they behave in a similar fashion. The noble gases are group 8A. So this is a noble gas. The alkali metals are group 1A. So you need to know the location of these groups and families. So when I say, I could ask you a question about an element. For instance, is sodium an alkali metal or an alkaline earth metal? And you would have to know which group is which. Now I put letters after these. So A, 1A, 2A, 3A, 4, all the way up to 8A. Main group elements are the ones with A after them. So groups belonging to A. So all the ones I just went over are main group elements. Now the transition metals are B. So all of these are considered your B, transition metals. Now your inner transition metals, this kind of island that I was referring to earlier. So this is your inner transition metal. These are referred to as the lanthanides and the actinides, but we don't get that specific. Now I want to point something out about the inner transition metals. Go to your periodic table. If you look at lanthanum, it's number 57. And then you look directly to the right of lanthanum, hafnium is 72. So there's a jump. This jump doesn't really make sense unless you look at the island to the bottom. So the island goes from 58 to 71. So it kind of fills in that missing gap. And if you do the same for this lower actinium, it goes from 89 to 104. And again, that jump is accounted for if you look here. So these bottom ones really are the inner transition metals. It's just, you can't represent it very easily on a periodic table. You can't expand that without just taking up a very large portion of your paper. So, it's important that you know the families, groups, and periods for this course. So we will definitely ask you questions about the alkali metals, the alkaline earth metals. Where are they located? Is this element an alkaline earth? Is it a halogen? Is it a noble gas? Etc. So on the next page, I just want you to kind of label this blank periodic table. So I want you to hit pause and try and just write on them. Okay, so I put alkaline metals, alkaline earth metals, transition metals, inner transition metals, metalloids, halogens, noble gases. Note that, I'll put this in green, these are main group in green, and the rest for transition. Just kind of an example question for you. I want you to identify a halogen that is in period 4. Period. Now, is a period, does it go horizontally or vertically? It goes horizontally. Now, the way periods are numbered, which I didn't talk about this is the first time I talked about this, it's just, from top to bottom. So this is period 1, this is period 2, this is period 3, and this is period 4. So you would need to go across you need to find a halogen that's in period 4. So what would that be? So if you look on your periodic table, halogen in period 1, 2, 3, 4 is going to be bromine. The answer to this one is bromine. If I asked you another question, noble gas, period 4. So noble gas, same period. So that one would be right next to bromine. It would be krypton. And if I asked let's see, alkali metal, period 2. What would that be? So alkali metal, period 2, right there. That would be lithium. So be careful with these groups and families that we just learned. A lot of students will confuse halogens and noble gases. Also, alkaline metals with alkaline earth metals. So make sure you know the difference, that group 1 is alkali metals, group 2 is alkaline earth metals. Halogens are group 7A, while noble gases are group 8A. So just be real careful with those. But as long as you know these, you can get a lot of easy points. Okay, so we're going to talk now about the atomic structure of atoms of a given element. So if you had the best pair of scissors and you were able to cut things as small as possible, you were able to cut this piece of aluminum foil as small as it could possibly go. In other words, your scissors weren't the limiting factor. Would you reach a point where you couldn't cut this piece of aluminum foil any smaller? And the answer is yes. So, your scissors are normally the limiting factor, but if you had the best pair of scissors, you would reach a point where you couldn't cut this aluminum foil any smaller. If you got to that point with these scissors and you couldn't cut it any smaller, you would have an atom. So an atom is the smallest and simplest piece of an element. So it's the smallest and simplest piece of an element. And the important thing about an atom is that it can still be identified as that element. So we put in the parentheses, still can be identified as that element. So, in an atom, there are subatomic particles. So it's a little bit smaller than the atom, although you wouldn't be able to reach these with your scissors. So the subatomic particle in an atom, we have a proton, we have a neutron, and we have an electron. Now, the masses of these subatomic particles, very, very small. So small that you have to use scientific notation. If you didn't use scientific notation, you'd be using a lot of zeros, times 10 to the negative 24th. So that's 23 zeros. It's inconvenient to use grams as this unit of mass for expressing these subatomic particle masses. So what's been developed is AMUs. These are atomic mass units. So the atomic mass units are based on a relative size. So it's based on carbon. So it turns out that carbon atom has 6 protons and 6 neutrons, which is assigned 12 atomic mass units. And carbon is found in everything living. So organic chemistry deals with carbon, so that's why it was chosen. It's just all over the place. That's why we based our atomic mass units off this. So if you express the masses of the subatomic particles in AMUs, you don't have as many zeros. So it's just an easier way to account for this mass. So for instance, the proton has a mass of 1.007276 AMUs. A proton has a positive charge. So it has mass and it has charge. It's a proton. Now a neutron also has mass. It's a little different than a proton, but overall it has a mass of 1 AMU. So it has mass. A neutron does not have charge. It's 0 charge. Now an electron has a mass much smaller than 1 AMU, 5.485799 times 10 to the negative 4. So it's much smaller. In fact, we can kind of neglect this mass due to the electron because it's not contributing to the mass of the atom. Now the electron does have a negative 1 charge. So it's kind of the opposite of the proton. Okay, so how these subatomic particles are arranged. So protons and neutrons are in the nucleus. They both have mass, remember. Remember the proton has a positive 1 charge, the neutron has a 0 charge. They both have mass. While electrons surround the electrons surround the nucleus. Now remember the electrons have the negative 1 mass. So the nucleus is made up of the protons and neutrons. These have mass. And the electrons surround this nucleus. So they kind of spread out really far. It's a negative 1. So the nucleus of an atom is very small compared to the size of an atom. If you think about the total atom as being a large dome stadium, the nucleus would be the size of the pea. So you have this huge football stadium. And then in the center of the football field, you have this pea, just a green pea. That's the size of the nucleus compared to the rest of this massive stadium. That's where the electrons are in the rest of the stadium. So the electrons really spread out. So, just gives you an idea of how large this electron cloud is. Now, if you've ever seen a speck of dust, in the sunlight, you think you've finished all your house cleaning, and then the sun just hits the floor just right, or it hits that table just right, and you see these little specks of dust, and you think, I just dusted that table. There can't be any dust there, but there is. Anyways, this speck of dust. So one of those specks of dust, how many atoms do you think a speck of dust contains? Quite a few. In fact, a speck of dust contains 10 to the 16 atoms, which is quite a few for a little tiny speck of dust. Yes. So that just gives you an idea of how small atoms are. And then if you think about it, a smaller scale, the atom. You have the nucleus, which is the center of this atom that contains the protons and the neutrons, and you have this electron cloud that surrounds this nucleus. So the whole atom is a large stadium, and then the nucleus is tiny compared to this large stadium. It's just the size of the pea, like we mentioned earlier. So now in terms of attraction, what holds this atom together? Opposites attract. So this is kind of what holds the atom together. Now the subatomic particles that we've talked about that have opposite charges, that's the glue that keeps this atom together. Do you guys remember what the subatomic particles are that would be attracted to each other? The protons are attracted to the electrons. The protons have a positive one charge and the electrons have a negative one. So you always hear that saying that opposites attract. And it is true in chemistry. You don't necessarily think that opposites attract always works in relationships, but I'm sure there are a lot out there. So at any rate, I'm going to stop this lecture for now. We talked about the arrangement of the periodic table. We learned about the groups and the periods, the families, alkaline metals, alkaline earth metals, transition metals, metalloids, halogens, noble gases. We talked about atomic structure, learned about protons, neutrons, and electrons, and we're going to go on further with that in the next lecture. But I want you to do your homework for these sections that we've just gone over, and definitely work on knowing your groups and families on the periodic table, because those are easy points. You don't want to miss those. So, all right, until next time.